Yes, sir. Now you just square root, no, square, x square over 4 is, square root over 4 is no, x over 4 is x squared. So,
There's no square root in the
okay.
second part limits.
Sir? Sir? Come.
Everybody open the back of your notes. Let's do a short test. Yeah. Let's do a short test. Let's do a short test. 2 divided by 0, write your answer. 2 divided by 0, write your answer. Next one. 4 multiplied by 0, write your answer. 4 multiplied by 0, write your answer. The next one, how do the next one, 4 multiplied by infinity, write your answer. 4 multiplied by infinity, write your answer. 4 times infinity, write your answer. Are we there? Are we there, please? Infinity divided by 5, write your answer. Infinity divided by 5, write your answer. I hope some people are writing question and answer together. Who is writing question and answer? Because by the time I start calling so that you tell me, then I tell the answer. Where am I?
Infinity divided by 5.
Infinity divided by 5. The next one, 7 over infinity, write your answer. 7 over infinity, write your answer. Have you done that? The next one, 0 divided by 0, write your answer. Next one, infinity divided by infinity, write your answer. Are we there? The next one, 0 multiplied by infinity. 0 multiplied by infinity. Are we there? Infinity divided by 0. I'm not imagining the answer. Imagine someone just writing 1. They are telling me infinity cancel infinity 1. Okay? Where am I? Where am I? Where am I?
Infinity divided by 0.
Infinity divided by 0.
Infinity divided by 0. Have you seen it? Okay. 1 raised to the power of infinity. Write your answer. 1 1 raised to the power of infinity. Have you written it? 1 raised to the power of infinity. Write it. The next one, infinity raised to the power 1. No, sorry, it shouldn't be infinity raised to the power 1. Next one should be infinity raised to the power 0. Sorry. Infinity raised to the power 0.
How many
is that? Alright, let's start. Let me start saying the answer. What's question number 1?
0 over 2
is what?
0.
Okay, that's correct. Next one.
2 over 0.
What's the answer?
0. 0.
I wrote hello. Let me take 5 minutes of your time, of our lecture time, to catch you small before I continue. I wrote 0 over 0. I mean, that question I just did. What is it?
2 over 0.
I wrote 0. Raise up your hand. Don't lie.
Don't lie.
I wrote 0.
Raise up your hand.
Clap for yourself. Brilliant students. Now, for time's sake, you can't divide anything by 0. So which means that anything divided by 0 is not infinity. It is undefined. So if you wrote infinity and 0, you are wrong. The answer is what? Undefined. Next one.
You didn't put it there, exhibit.
Yes. Next one. Abba, yeah. 0. Next one.
4 times infinity.
Infinity. Okay, let's take that infinity.
Infinity divided by 5.
Infinity
divided by 5.
Infinity.
Don't know about
Divided
infinity.
by 5 is infinity.
Don't know about infinity.
Is what?
0.
0.
0.
The answer is 0.
I got it. I swear, everything I wrote, I just wrote 0 and everything. I don't know.
Next one.
I don't know the answer. 0. 0.
Infinity. Who's that one? Who said 1?
Divided by 0 is undefined. Next one.
Secondary school group.
Divided by infinity. Again, it's also undefined. Don't say 0 is not 0 and it's not infinity. Next one.
Oh, come willing secondary school.
0 times infinity.
0 times infinity is undefined. 0. Undefined.
Undefined.
Next one. Divided by 0 is what?
This person.
The next one. What is my
still
infinity?
At the control stuff. At the computer. What's it here?
What is my infinity?
I'm using it to do.
Undefined.
I want to shape it.
The next one.
Carry shape and back.
Infinity raised by 0 is 1. Infinity raised by 0 is 1. That is undefined. I did one more. And let me there are like 6 outstanding ones. There are like 6 indeterminate forms. Now, first of those indeterminate forms is that something divided by 0 is indeterminate. Asterisk that stuff that I'm saying. Those are indeterminate forms. Something divided by 0. undefined. The next one that we have is what else gave us undefined?
Hello.
0 divided by 0 is an indeterminate form. Asterisk it too.
Just like this being different.
Undefined, yes. All the answers that I gave you as undefined, asterisk them.
0 divided by 0 is undefined.
0 divided by 0 is undefined. Anything divided by 0 is undefined. 0 times infinity is undefined. 1 is for infinity is what? Undefined. Infinity divided by 0, undefined. Infinity multiplied by 0, undefined too. Infinity over infinity is what? Undefined. So all the answers I gave you undefined are what? Are called indeterminate form. Now for the next part of limits that we are entering, anytime we see indeterminate form, we would apply L orbital rule. Yes, write it down. L orbital, that is L apostrophe orbital.
It's Otugbe Debe.
Is it your SS2? This boy.
All over go me boy.
L orbital rule. L orbital rule, as I said. L orbital rule. You use this form. Please listen. You use this form whenever you have what? Indeterminate form.
Where did you draw them?
I'm not drawing now.
I'm not drawing. You play draw go.
Back to what I was saying. Anytime you have indeterminate form, you apply L orbital rule. And what is the concept of L orbital rule? L orbital rule is used when we have indeterminate formulas, as I said, and it's all about differentiating your numerator separately and your denominator what? Separately. All things being equal, because in this thing there's 1, 0, 2. Yes, and for those of you guys that might have attended my class last semester, I taught this thing too. Alright, good. Now for this next section, there are about like 40 examples. But I'm not going to do that 40 examples. I will pick anybody at random. And let's see. How many examples did I do in the first part?
12.
I did 7 now. Did 7 or 6? 6. For this next set, I'll call any 7 person at random. Do not overthink it. Pick any number from 1 to 40. That's just it. Don't overthink it. Are we together? Just don't overthink it. Pick a number. How we get 5 points? Should we start? Yeah. Now, the bro with red, face card black, Nike.
Yeah, it's on the screen, bro.
We are called, please. Just don't have to call me yes. This is a call number. Number 1. Call number 1. Okay, no problem. We like big simple ones. I don't want to sabi. Help someone write number 1 down for me, please. Sister with how do I describe? What's the name of this your clothes here? No, that's all. Is it? They are pink.
Casted.
140. Pick a number. 12. Yeah, every night number 12 down. Top brother at the back. You. I think you're the tallest in that back, yes. Don't stress. Just sit down. 35. Write 35 down. Fine work. Pick number, Mama. 11. Write 11 down, please. Just start the black one now. Versas, yes. 17. Okay. But I don't can you want to pick number?
26.
26. How many is that? That's 6. One more person. Sister with the color headgear. I don't know. Is it not color? It's color now. Oh yeah, pick number 140. Don't overthink it. 40 itself. 14. Alright. What's the number 1? So I asked you to pick the number at random. So if I do not do some part I'm supposed to touch, it's not on me. I want to ask you to pick at random. Next number 11. 11. Limit as x tends to 4. X cubed minus 64 all over x squared minus 16. Next one.
26.
What's the next number, please? Am I the question this is the number? 26. Limit as x tends to 0. Minus 5 plus x 1 minus 5 minus x. Oh, sorry, not 0. Number 6. 14. 17. 14. 17.
Gbé mi débẹ̀. Mi ò lè rí ṣe.
Number 1. What is all this? First thing I have to do is simple. I always get at this. Now, first in your mind, before you do anything first. So provided you are doing limits, first thing I'm doing is that, first of all, plug in that limit inside your x and check if you have an indeterminate value. That's the first thing. Whatever answer, let's begin. Whatever limit you have here, I get my point. In this inside this entire function, if you will have an indeterminate answer, what will you use? L of theta. But does not have an indeterminate answer, where will you answer like this? Yes, I get my point. Let me go so that it doesn't look like a problem. And number 1, we have limit as x tends to 2, or what? 5 minus x. We know that if I put 3 there, I cannot have an indeterminate from that. We just plug in 2. 5 minus 2 should give us 3. Number 2, limit as x tends to 2 for x power 5 minus 32 all over x cubed minus 8. First question, look at it. If I plug 2 here, will I have problem or not? Will I have problem or not?
There's problem. Yes.
Because 2 raised to power 5 is 32. 32 minus 32 my numerator give me what? 0. 2 raised to power 3 is also what? 8. 8 minus 8 give me what? What do we do? L of theta 1. And what does L of theta 1 mean? You differentiate your numerator separately, your denominator what? Separately. Limit as x tends to 2. Differentiate this one end up having 5x all about 2. Now from here, you observe that by plugging in my 2 here, I will not have any undetermined form again. Yes or no? Yes or no? So just plug in 2. 5 times 3 to the power 4 all over 3 times 3 squared. If any I want to do, this is 5 times 16, it will give me 8c. 3 times 4. That's 12. And how many if you divide? I don't know. 2 I don't use 2. And I use 4. Yes. That will give me 20 over 3. And that's my answer. Sure. You understand? Yes. Number 3. Look at it now. limit as x tends to 0 of exponential x minus x minus 1 all over x. Observe, if you put 0 there, would there be a problem or not? If you put 0 inside that function, would there be a problem?
There will be.
Are you sure? Yes. There will be a problem because exponential 0 is 1. If you put this one here, all I know about 1 minus 0 minus 1, and that's what 0 in my numerator. If you plug in 0 here, all I know about my numerator, 0. So I cannot use it like that. What do I have to do? L of let's differentiate. Limit as x tends to what? 0. Differentiate the exponential by exponential x minus what? Minus 1. Then I calculate my numerator if you need now. Yes or no? Yes. Then for me, I can now immediately put in your answer. Answer your own I don't have in here. Please do not be scared of it. 0 is answer. The only thing you have to from is what? Determinate. 0 over 0, infinity by infinity, and all of those terminate from like that. I will get that. Number 4. Look like this. Limit as x tends to 4, x is power 3 minus 64 all over what I have in x squared minus 16. Observe. Plug in for here. Will I have a problem or not? Will I have a problem?
Yes.
Yes, I will, because 4 to the power of 3 is 64. And 64 minus 64 will give me what? 0. 4 to the power of 3 is 16. 16 minus 16 also give me what? 0. So, end of that rule. Limit as x tends to 4. What do I end up having here? 3x squared all over 2x. So, plug in your 4 now, without having any issue. That's 3 times 4 squared all over 2 times 4.
Okay, as x tends to means x is equals to 0. X is equal to 4. Why? Six. I don't know what's this for.
I would say that please. Now let's go and do the last three, which you think might be hard, but at the same time it's not hard. Okay. Separately, separation, numerical separation, and also separation. Now look at number 5. First thing first, as I said, before you do anything, check. If I plug in 4, that's number 5. Will I have a problem with it? Check first. You plug in 4 in number 5.
Yes.
Because, for example, if 4 inside the square becomes 5 plus 4, that's 9. Square root of 9 is what? 3 minus 3. Now, if you do the same thing here too, plug in 4. 5 minus 5 is what? 1. Square root of 1 is 1. 1 minus 1 is what? Which means that this is a typical case where I have to use LHOPITAL rule. Now, I think I can use LHOPITAL rule and at the same time I can factor. I mean, what do you call that thing? So, rationalize. But I think differentiating here would be smarter, provided you know how to handle your differentiation without having any issues. And this square root of x in, I can write it now as limits as x tends to what? 4. 3 minus 5 plus x is power what?
1 over 2.
All over 1 minus
5 minus
5 minus x, 1 over 2.
1 over 2. Don't forget power rule. For example, if you have something like this, let me lay down the foundation of what I'm using to differentiate. Suppose you have 4x minus 5. So once you put one number, any number, I had 9. 11, 99. One number equal 99. So for what else to differentiate this? What trick do I use to differentiate? The other power I have on top, I write it out first. 9. Multiplied by differentiate what is inside. 4. Multiplied by write your question back and you come from your power. 4x minus 5 power 8. And by the time you multiply it, you give what? Then 6, 4x minus 5 minus 1 over 2,
1 over 2
Minus 1.
minus 1. That's the question here. 5 minus x minus 1 over 2. I would say that this. Then by simplifying your entire numerator here, simplifying, what do you observe as our by simplification? So this one you're going to as x tends to 4. So I have minus 1 over 2. This entire thing here can be written as 1 over square root of 5 plus x. Yes or no?
Actually,
Yes. Right. Same thing here. I have 1 over 2 times 1 over square root of what? 5
minus x.
As a half cancel half. Then you can plug in your limit inside. So what this one giving here? Minus 1 all over 5 plus 4 all over what? 1 all over what? 5 minus 4. Because of 5 minus 4. Then we know that this one here will give me what? Minus 1 over because of 9 will give me 3 all over 5 minus 4 is what? 1. And square root of 1 will give me what? 1.
1 over 1.
1 is what? 1. Final answer is what?
Minus 3.
Minus 1 over 3. That's all. I will apply the same property here to question 6. Yes? How did it? 3 is a constant. And if you measure the constant, you have 0. And that's why it disappears.
More Gagi.
I can explain again. I think if you realize, plug it in for you will give me 0 over 0. So let's just differentiate. But
The
before
fear
I
of
do,
God is
let me
bigger
write
than
this
wisdom.
such way I can handle. Square root is saying that I take something 1 over 2. Then differentiate. 3 and 1 are constant, so they give. I think I have minus here. Is there minus here? How am I talking to the front? When 5 plus x. How am I talking to the front? Exactly. Why is this 3 here? Then subtract 1 from the power. So that it was half here. By subtracting 1 from half, it became minus half. Same thing happened here. Then just simplify to get the answer. Okay.
Power bank. I cannot see it. What you gonna know? Don't be distracted.
This one. This one here. Yes. How do I get it? If I get minus x. If I get minus x here, I have minus 1 now. And I get my minus 1. Any other issues? Right. Now looking at question number 6. Applying the other without here will also give me what? Give me a problem. I guess my point is this. So I mean, I said applying the other without give me a problem. Plugging in my unit here give me a problem. So let's differentiate. Number 6. If I get it down number 6, what would I have then? Limits as x tends to a. How am I going to come to the front? 5 over 3 times. Depending on what you have in your denominator here. 1. Then write your question root 1. X minus 2. Raise to power 5 over 3 minus 1 should give me 2 over 3. Oh, x plus 2, thank you. Now I want to show you a plus 2 raised to power 5 over 3 is a what? Is a constant. Yes or no now? A is a constant, 2 is a constant. So the entire thing raised to power 5 over 3 is a what? Is a constant. And if you can get a constant, what do you end up having? So there's no need for me to differentiate this. Or you can later give it 0. And everything here divided by if you get x minus 2, what do you end up having here? 1. By the time you plug in your a here, 5 over 3, open bracket, a plus 2 over 3. If I put in a here, I will have problem because it will be a plus 2, they are same thing. So differentiate. Power on top here, a to the front, 5 over 3. Differentiate x 1. Write this entire question and do 1 to the power. 5 over 3 minus 1 give you 2 over 3. Now, I still like to retain this entire thing here. It's a 0 because it's all a constant. So that's why I'm not putting it here. If I get x minus a here, what do I end up having here? 1. Then I can now confidently plug in my what? My limit. Anytime I see x, I just get a. 5 over 3 times 1 is what? 5 over 3. Then a enters. Solve it. No issue. Alright. Everybody, you are trying this number 7. Let me answer. Try number 7 and let me answer, please.
H tends to what? H tends to what?
H tends to 0. Yeah, everybody try number 3 and then number 7. Try number 7 and then the answer. For number 7, the answer is 0.
I'm not done.
So the answer cannot be 0.
It can't be done.
H tends to 0. One. Answer is not even 1. Let me help you.
What's x?
X is just there. Let me help you. The answer is not even a number set. It's not undefined.
Minus 1 over 2.
No. It's not in decimal.
Infinity. Infinity.
How do you want to have infinity inside this place? Differentiate job. H is a constant, yes, definitely. Yes.
What about definitely?
X plus H.
1 over 1.
Then that means you see that if you differentiate here, it shouldn't work. Then take conjugate.
Also conjugate.
Rationalize. Because if you differentiate here, see, H is a constant. And if you differentiate the constant, what do you have? And I have something divided by 0. So rationalize.
Okay.
Rationalize and that's the answer. Rationalize and plug it in.
Also naturalize.
Yeah, never rationalize.
We know it.
Ah, no more.
Time is positive of this one.
So I don't understand. I don't know. I mean, I will not lie. I don't know. Maybe it's another English they used to use for me, but I don't. I don't understand.
Multiply up and down by the conjugate of up. That rationalize.
Conjugate.
Conjugate. Take that sign for minus and plus.
This one.
We did it previously before I started.
Okay, multiply by the opposite.
Multiply up and down by the conjugate of the numerator.
Ó ti yé mi.
The same thing, but that sign in between will change from minus to plus. All the signs in between the source will change. What's the answer? 1 over 2x squared. Yeah, yes. I mean 1 over 2x, sorry. I mean now.
Ara o mi ò mọ̀. A lè máa sọ yes. Sir, ẹ wo mi ò mọ̀ o. Ah, èwo ni yes? Eh?
X plus h minus square root of x, square root of x plus h plus square root of x. Square root of x. What about x plus h plus square root of x? Then if you observe, numerical limits depend on two squares. As h tends to 0, square root of x plus h squared minus square root of x all squared all over h square root of x plus h plus square root of x. Now by the time you put the square, keep it as h tends to 0, x plus h minus x h square root of x plus h plus square root of x. X will cancel x. That will be h tends to 0 plus h over h x plus h plus square root of x. H cancel h. We are left with limits as x tends to 0 plus 1 over square root of what? X plus h plus square root of x. What do your 0 here? 1 over square root of x plus 0 x. So it's not a x, it's h. And by the time you have 1 over square root of x plus square root of x, 1 over what? Square root of x. That's the answer. But you don't get it.
If you say yes, I will punch you.
The last part of limits for your level actually. The last part of limit for your level is trigonometric limits. Trig limits. Trig limits. Trig.
Ah, ẹ wo ara kan mi o.
Trig limits. Where's the calculator, please?
There's one in my pocket. Dogoni, if the calculator can do all this thing, is it possible?
They say calculator can do it, but I don't know. They say I can do it, I don't know. Rather than learning calculator, I learned the trick myself. So.
It's in a scam, Gary.
Attention, going exam. Shut up your mouth.
Censé ou non? Hello! One of these, please, Ejo.
Not you. Tinubu. Not you. Not you. Manu. Okay, but what are
You can use that when you are doing CBT. So that one is when you are having written. Or you are doing complex, doing analysis. See, I got my point. You are doing CBT. Now for the next section, which is trig limits. that's where we are. The next section, which is strict limits. There are 72 questions here. And as usual, I know that the first one you picked, what do you call? You picked 7 out of 40. I did the mathematics about like 7.5%, or what I did. And this time around, we are going to pick 13.
I'm videoing you, guy.
So as usual, I call everybody to random. And this time around, let nobody pressure you. Pick any number that comes directly to your mind. I'll get my point, please. The last border that corner. Pick number 172. 72 itself. God bless you. Next, should I call my boy? You.
What?
You.
Number 7.
Number 7. Or 7 left. My boy. Go. 18. You will not. 37. The sister beside you, big. 62. I love that. My boy, number 172. 19. I give you this 62. 19. But I don't take a look at it. I don't take a look at 21. God bless you. You. Yes, wait. Yeah, 172. 20. Who left and will bring you now?
Ah, lóbìnrin Sems lawa. Na senior men. We have men and senior men.
Yeah,
70.
Hola.
I meet you. Eh?
10. But I don't know yet. Big number. Yes. 65. God bless you.
82. 82.
How many is that? Look at the go. Number myself. Number 1. So now, please, every arrange your number. Arrange that number, please, from the highest to the lowest. Yeah. Arrange from the highest to the lowest. I mean, lowest to the highest. Sorry. Lowest to the highest.
The highest is the toughest part. One for me.
Nothing for you.
Legacy, one for me.
Nothing for you. Ah.
Sit, Jordan.
Lowest to the highest.
Boy, Gary and the Thailand will never be reward.
Yeah, let's go. First one. 1. What I want to do on the board might look like magic. Boys, I don't know what's okay. Anybody who have push it back. Over and I'm put your phone on silent, please. It's already 7. I'll be on the first topic. Don't worry.
Guy, I need water.
Tó fi mú gàrí ah. Don't have to. I want to eat. What is gàrí? I want to gàrí. When I bring something, I want to use it.
Whenever you have sign over a linear function. Guys, listen, man. Whenever you have sign over a linear function. Whenever you have sign over a linear function, I want to be over a linear function. Anytime you have sign over a linear function, tan over a linear function, form over a linear function, cosec over a linear. I don't call 4 chick functions now. I repeat, sin over a linear, cot over linear, tan over linear, And what's the last one?
Cosec.
Cosec over linear.
Whatever you should do is just extract the coefficient of x in that form you have, and that is your answer. Extract the coefficient of x, and that's your answer. Therefore, 3, 4. So which means that here, my answer is what? 4 over 6, and that's what?
2 over 3.
That's all. Closer. Next question, please. Question 7 and 8. Alright. Limit at x tends to 3 sin fx over sin nx. Now here, as I said, that trick only works when you are dealing with sines. All of those 4 tricks that I called works for it. You are getting my point now. So what?
When they go anywhere.
Yes. Here, as I explained to you, since both of them is sine and tan, what I want to do will work. Just extract the coefficients. So the answer here is what?
M over N.
That's all. Please note, it only works for, how does it work? I said, either it works for sine, cos, tan, cosec over linear, or any of those divided by themselves. You know, like, either you have sine, tan, cos, cosec over linear, or you have any of those two divided by themselves.
What about cos?
Don't answer next. They will. If you pick cos, I will treat cos. Provided you pick it. You get my point. So there are 2 conditions. Condition number 1. Anytime you have any of those 4 strict conditions I call, all over a linear, extract coefficient. Second one, anytime you have any of those 4 dividing themselves, that is sine over tan or cos over cosec, any of those ones, extract their what? Coefficient. Next question, please.
18. What? You said 4. 18. What about Guinea cosec and cos?
Sine,
cos,
cosec.
tan, cosec. What about Guinea?
Cos. That one doesn't work for it.
Cos. Don't even go.
18 and So in this case here, you can write this stuff here, so that we can have some number of coefficients. Sine 1 over 4x, 1 over x. Both of them are linear. I have sine over linear. So let's go. That's what?
1 over 4.
1 over 4. Next one. 19. And x all over 2 all over 3x. Right, so that you can have your linear formula. Yes, it's 1 over 4. Yes, that's always there. It's not always 1 time in 3. But for these cases, you see stuff like that. I have your time 1 over 2x over 3x. So what is my answer here? 1 over 2
over 3.
And
That's 3 over 2.
1 over 6. Number 5, next. 20. Okay, finally we have 1. Limit as x tends to 0 of 1 minus cos x all over sin squared x. Now, the rule breaks here because by the time you observe it, I have a cos, and even the sign that I even have here is a what? They have a power. Now I want to do some stuff here. 1 minus
Plus 1.
0 is what?
1, 1.
1. 1 minus 1 is what?
0.
Sine square 0 is same thing as what? 0 now. So I can use L of theta rule. And what is L of theta rule? Whenever you have 0 over 0, is that not so? Now another way I can use this is very smart. I will take my time, provided you can remember trick. Even though you don't know trick, you can use L of theta rule. Nothing spoil. But here I want to use trick. In trick, you know that sine square x plus cos square x
Equals to 1.
equals to 1. Then for you to have sine square x, they do I cos square x to the other side, which means that sine square x
1 minus cos square x.
So if I write this entire thing here, that going to be 1 minus cos x all over what? 1 minus cos square x. Now if you look at this your denominator, I can write 1 as what? 1 square. Yes or no? Then I can now apply difference of 2 square to my denominator. Limit x tends to 0. 1 minus cos x all over
1 plus cos.
1
1
minus
cos
cos x.
x. 1 plus cos x.
1 plus cos x. So what happens?
Cancel each other. Right, 1 over.
Limit x tends to 0 of what? 1 over 1 plus cos x. I know that if I put 0 inside here, I will not have any problem again. My final answer is just what? 1 over 1 plus 1. Because cos 0 is 1. And that's what? 1 over 2. This is one way. L of theta depends on how you know how to differentiate sine square. For that same question, provided you know how to differentiate, limit as x tends to 0, 1 minus cos x over sine square x. If I differentiate the numerator, what do I end up having? Minus sine x all over. Differentiate sine x, which one to the front first? 2. Differentiate sine x plus x. Write the question and put 1. Sine x. So reducing this one here, we have sine x all over 2 plus x sine x. Sine cancel sine. I left it for 1 over plus x. Then put in your number back here. 1 over sine 1 over 2. As I said, provided you have to differentiate, can use this.
O ti pè mí débẹ̀. I refuse to be confused. No. Just leave this abeg. It's man.
1 minus cos 3x all over x squared. If you look at this one now, you observe they are plugging 0 because the problem. Look at, I mean now, let's do L of theta rule. If you differentiate this minus, differentiate cos 3x, what I have? Minus 3
Sine x.
all over
2x.
2x. By the time you expand now, you have what? 3 sine 3x all over what? 2x. I can now apply that structure I told you. Now, whenever you have x over linear, write out your coefficient. But do not forget this thing here also. So, which means it's going to give what? 3
times 3 over 2.
And that's what?
9 over 2.
Next one. 24. As x tends to 0, 1 minus cos 4x, 1 minus cos 6x. Now, looking at it here, if you plug in your 0, where is it now? L of theta rule. Minus, differentiate cos 4x. Minus 4.
Minus 4.
Buy something and check bien.
Minus 6.
Sine x.
Then by simplifying that limit, x tends to 0 of what?
4 sine 4x over 6 sine 6x.
Sine 6x.
4 times 4, 6 times 6. 6 over 36. 1 over 2. 1 over 2.
No, right by 4 over 9.
Guy, are you not right? Guy, are you not right? It's like because I will still call you done. Hey, question, are you not right? I want you guys to do with that. Let me see. I don't like passing.
No, really.
Oh, he knows what.
No, really. I'm still looking at the problem. See, Davis, the problem that not making me out to see. I'm still drinking it again.
Let's go. Login 0 here. You give us a lot of problems. Elemental. I'm making my time here because I know that mistakes will there will be mistakes here. Differentiate. And next we give you x squared x. And next we give you what? Yes. Now check again. If you plug in 0 here, will I have digits? And let's see. Sec is the inverse of cos. So which means that cos 0 and sec 0 is the same thing.
Wow.
0 minus 0, I mean 1 minus 1 all over what? Sec is the inverse of cos. And sec 0 and cos 0 is equal to the same thing because cos 0 is 1. Definitely sec 0 is 1. So if I put in 0 here, I will have 1 minus 1 all over 0 and that's 0 over 0. What do I do again? L'hopital. Now, for this l'hopital here, limit as x tends to 0. Take it easy now. I want to differentiate with x squared x. I can write the answer down, but then you guys start talking about how can I see it? X squared x, write it down. And sec x all squared. 2 on top, 1 to the front. Differentiate sec x itself. Now sec x and x. Then write your question back here. Sec x. 2 minus 1 here. Give me 1. How to get at this? By the time you multiply this one, you don't know to power of 1. To multiply this, it will give you what? Sec squared x and x. If I relate this, you have 2 sec squared x and x. I hope you know that if I get minus cos x, you have what? Plus and x all over what? X. Now looking at it again, try again. Running 0, will I have l'hopital? Now because for example, tan 0 is 0. That's my point here. Tan 0 is 0, so 0 multiplied by anything that we have there will give me 0. Sin 0 here is also what? Also 0. So I have a 0 plus 0 to give me what? 0. Plugging in 0 here, 6 times 0 also give me what? 0. And I have 0 over 0. What will I do again? L'hopital. So you keep using l'hopital until what you have are shifted away from what? 0 over 0. Now, for me to differentiate sec square x and x, I'll just put up 2. Let's put up 2 differentiate. Limit x tends to 0. We have space for 2 sec square x. If you differentiate tan x, what end up having?
Yes,
X plus right tan x.
Tan x.
If you measure 2 sec squared x, first of all, write your 2 out. I think I just measured sec squared. Give me this answer. So which means that if I measure sec squared, what will I have?
2 sec squared x tan x. cos x plus cos x plus x over 6. Ah.
By the time you multiply and compare,
No, you don't waste time, please.
sec 4x plus 4 times square x sec square x plus cos x all over 6. Now, from here, I know that if I plug in 0, I will not have
1 over 6.
because 4 0 give me 1. So let me just plug in everything here. Let me show you what it looks like. Plug in 0 here, and we have 1 plus 4. Times square 0 is what? 0. 1 plus what is for 0 here? 1 all over 6. Then at the end of the day, what I end up having here? 2 plus 1 all over 6. 3 over 6 and that's what? 1 over 2. So that's the whole concept. Say, use L'Hopital. Anytime I use L'Hopital, you continue using it until you get to what? To something that will shift away from what? And indeterminate form.
You can't solve it within 5 seconds.
And likely you are not able to see this kind of concept.
So can we just pick?
And you can speak. You know how to put up for you. And which I know that my people will not. And here, I will say what this man said. What Gabriel said in the beginning. That every time you have something, most of this answer, you don't have to trick you. Like I say, option A 0, option B 1, option C half, option D 2. You will know that everything that produces is money. Has always been regulated between 0, 1, 2, and half. So you will not know which one to pick when you solve. This one does happen to be like that in this case. So that everything that produces money was solved.
Like the progression there, safe. When you go lock, like there's a way that will see the answer. It was in this square, the answer will be 2. It's over near the 1. Oh, yeah, now. Excuse me, I don't know that yet. Sir? Sir? That's the thing I only myself. I'm not going to ask. Yeah, the MTS, you know, my take cost of money in semester. And there's my just I didn't do it. I do, they do so too. I do the MTS so too. What is it 311? MTS delayed but this is 7 semester 300. 7. I know that.
Yeah, fair. Go pay.
Fẹ́ gbá mi bẹ́ẹ̀ ojú.
Give me don't plug. My phone on. Don't see no plug. Don't see no plug.
I heard that there is a current tutorial going on. I don't know if that started. But they say it's a 12-hour tutorial.
Yes.
12 hours tutorial, 500. They're currently holding at
FBN.
So, I'll be frank. Don't feel that I'm not saying it's not attend because number one, considering this our current space, I don't know, we might not even be able to finish anything that we're doing. MTS 201 is too much to finish in either 12 hours or 24 hours. Yes, it's too much. You can't finish it.
You finish MTS.
You can't finish it. You can't just finish it.
You can
So, I'm saying this because if you have not started reading MTS before, I just say that, okay, you want to use one night to cover it. Or you do
I have passed my boundary, sir.
or you do Oh yeah, are we not writing?
Yeah. No. Yes, sir.
That I saw the plan, I just started listening in my mind. Okay, let's minus the tutor away. Which amongst you here can sit down to learn for 12 hours? Have a day maneuver.
Me, even if I get a job by myself, I go sleep.
Active. I was like, it's a plan again. Grace, what's a plan? What's a body me bear, my little bear? I pay yes, it's more. Crown.
Try my best. I don't know where we can
Crown, we send I'm going there. Move the guy down.
I can't remember that.
Eh?
I can't remember that.
Eh? What are you from? Which video? I don't know.
Make I go.
What's all on our road?
It was the
I don't know.
bro. You know how much was on?
The seat to have off the seat on.
Yeah, Gabriel. I got
To ballistic, we look for me.
If I use A here, I will have no problem. So end up with that was x minus was A. Was A here the constant? So if you get the constant, it goes to 0. If you get was x minus sin x, if you get x here, you have 1. Minus A is the constant, so it goes to 0. Plug in your A inside here. And the final answer is what? Minus sin A.
The one called the course of the Jibe. The one the course in bed. I want to sign the answer. Hey. Those vibe pure now. Sorry.
One of the weaknesses, I'm gonna calm down.
Give me a time they go now. Sir, please continue, sir. Continue, sir.
Put in your back bench.
Hello, at least now.
I'm not alone, I need you.
And I think that I'm not going to function and sign.
Não
That's
assumo, não vai mais
whenever you have sign, linear function of any of those courses, extract
seriously.
so by extract
You dey go now.
What did I do again?
You dey block videos. In a live video shift. They go. Stand up, stand up. How long will you go sleep?
I differentiated, yes. No.
Mo pe iná wà bí mi lè ká wá Ọlọ́run. Ó tún wáyé kàbílẹ̀ kí n sọ pé ká lọ etí kò ní náà tọ́.
One plus Gabriel.
Take now.
That's got to 1/3.
What I have. See what I have.
Minus sign.
They don't like this one.
Minus sign. Where's the minus set to your One minus I guess it was it. Yes, wow. Two.
I'll get my point.
Yes, sir. Guy.
One over two.
I'm going to pay more to him. You're paying more.
How many? Be 10 for.
People that are you going to pay more apart from what you have paid? My non this MRI.
You need like send us anything. All these ones. I know you want to say you want to settle down.
They don't move our fast train. What's moving number one, I'm moving number two, I'm moving number three, I'm moving number four. How? How this? Okay, sorry. So
Legacy of FUTA.
Legacy by Gabriel.
What about?
Not limited to FUTA, babe. No limiting.
Before you go outside,
No.
A plus. Minus 1. This is a good one.
Okay.
Let me jump in. Look, you want to be close. minus 2. Go check.
What's it?
Sorry.
What's it game you did there?
Yes, it's true.
Ìwé mọ́.
Why is
Yóò ríran ọlọ́.
ti bọ́jú ẹ̀?
I swear it's clear like this, Aji. You can't blame me na Gary Kosa.
Love to the body. Okay, on charge.
Substitute and rely. They can put in your value inside. Don't happen about that. I'm not the limit.
Make I pay that. You go. Yeah, I can't.